Welcome to the very last video in the intelligence online lecture, Genetics versus Environment. Now, I'm already in deficit. I took too long on two of my earlier videos there, so I'm going to do my best to bring this in under time and just get to the point as quickly as possible. So, in essence, is intelligence genetically heritable? Do your genes and your background, your evolutionary and your personal background, your family history, influence how intelligent you're going to turn out to be? There's no simpler answer I can give on this than yes, it does. The real operant question is how much, relative to the influence of the environment and your life experience, how much of an influence does your genetic heritability have? So, the way that we answer these sorts of questions, because we don't necessarily know exactly what every gene and growth factor that is associated with human intelligence is, we don't have the resources to individually test everyone genetically and try to look for meaningful correlates that way, we tend to rely on overall heritability estimates between individuals that we're comparing. The most useful way to do this is familial comparisons, because in a typical family, people are genetically related to each other, and we know how genetically related they are to each other based on what their relationship is. Siblings have around 50% shared genetic inheritance. Same with children and parents, but it's 1/8 with your cousins, things like this. We not only have familial studies, but they have certain confounds to them. We also rely on adoption studies, where people have effectively two families: a family that they have not spent time with or shared an environment with that they do share genes with, and vice versa, a family that they spend time with but don't have much of a genetic relationship to. And we also talk about twin studies, because especially when you compare the difference between the two types of twins, monozygotic twins or identical twins, which are basically clones of each other, versus non-identical or fraternal twins, which are just siblings born at the same time. The nature of those genetic differences give you really easy parallels to see how much of a contribution anybody's genes make to particular traits that come out on the other side. So, to summarize it really quickly here, there is a strong correlation, let's say if we talk about just IQ, for example, between the same individual over time. You obviously have retest reliability, so you correlate with yourself at different points in your life. You have almost exactly as high a correlation for the heritability of intelligence with your monozygotic twins, with your identical twins, a bit less with your dizygotic twins, even less so for siblings who were born at different times. And as you might expect, it goes down and down through parents and things like this. Generally speaking, adopted parents and their adopted children only have around 0.16 of a correlation with each other. That's a very weak relationship. There is some influence going on there, but it's very small compared to the genetic components. In fact, my favorite way of breaking this down is just to say that, if we look at the comparisons on the screen here, is that fraternal twins, that is to say twins who are just siblings born at the same time, half related to each other, 50% genetic heritability, have about 0.6 correlations when it comes to their intelligence with each other. Whereas identical twins who are reared together have much, much more. They have around a 0.85 correlation with each other, around the same that you would have with yourself at different times in your life. Compare this with identical twins who are reared apart. Being reared together with your identical twin gives you a stronger, similarity to being reared apart from your identical twin. Reared apart, their correlation's only 0.72, whereas when reared together, it's 0.85. This is where it gets crazy, though. This is where it gets really exciting and interesting. Identical twins who are reared apart, that is to say they may have never even met each other, still have more similarity in intelligence than fraternal twins, people who are siblings born at the same time, who are reared together. That's how big of an influence genetics have here. If you actually try to parse out all of these correlations and say what is the overall contribution of any given person's genetics to the variability in their intelligence, you would say that we have a bit of a range on this. It varies a little bit from study to study, that at least 40 to 60% of the individual variance in intelligence is explained by genetic heritability. Now that's a lot as far as psychology variables on this go. Usually it's 40 is the upper limit, not the lower limit of what our expectations here are as a percentage of heritability. So that leaves really about less, only about half or less of all of the variation between individuals in intelligence that come down to differences of education and culture. So what is actually inherited along the way here, given that you don't inherit knowledge from your parents directly? If you did inherit knowledge directly from your parents, like my dad is a truck driver, so I would know how to drive a truck. My mom can speak Hindi, but I can't. You don't directly get information from your parents this way. What instead you inherit is the basic template of how some of your cognitive circuitry is going to form in order to then instruct how your brain puts itself together as you grow up. A really good example of this is impulse control. The circuits in your prefrontal cortex that help you suppress other desires that you're experiencing moment by moment. We'll talk about this in the personality lecture later on. These are responsible for your ability to plan for the future, to delay gratification, to make certain strategic choices that other people will fail to make because they're more likely to give into temptation. Again, I've included a video if you're watching this in Leo. I've included a video down below of the experiment I'm describing here. But when you want to test impulse control in children, one of the standards that they use on this was developed in Stanford back in the day. It's referred to as the Stanford marshmallow experiment. You give children a marshmallow and tell them, well, you can eat this right now if you want, or if you can hold off on eating it for a little while I leave the room and come back, I'll give you 2 marshmallows. It measures their impulse control in that way because the children are struggling with the temptation to not eat this marshmallow that's right in front of them. And this is from the video. Like, they really struggle with it. They come up with strategies to distract themselves and things like this. And the more successful children are at controlling their impulses at a young age like this, it is predictive of a lot of intelligence-like variables later in life. I mean, not only does it predict their IQ in later life, it predicts better test scores, it predicts higher graduation rates, lower BMI, better health outcomes. All of this because it is one of the structural underpinnings of your ability to control your behavior. Again, this is one of these things that shows a very high heritability directly from parents to children, and it's part of why we have a large factor of heritability to what we consider our general intelligence. Now, I've talked about, the genetic component of this. What do, your environment and your culture contribute to this? Now that we know what the genetic slice of it is, the two of them obviously interact in a number of meaningful ways. Certain opportunities provided by the environment can only be meaningfully acted on by somebody with certain kinds of genetic endowments. But for the most part, if we're talking about broad trends here, this is the takeaway message on this. A lot of this was discovered by patterns of IQ testing in children, allow us to discover what helps and what doesn't. Access to education vastly improves your IQ. Better childhood nutrition improves your IQ noticeably. Stressful or dangerous circumstances, especially while growing up, impair your IQ, growing up in war zones or poverty regions, things like this. Early intervention on any detected developmental delays vastly improves what somebody's IQ would have otherwise been in adulthood. High parental age, especially for mothers but also for fathers as well, because we accumulate a mutation load in our gametes the longer we are alive, impairs your IQ. You inherit more mutations that way. Exposure to toxic chemicals when you're young, for example, lead poisoning and things like this, vastly impairs your IQ, causes really strong deficits in that sense. And the amount of stimulation, diverse media, rich environmental challenges and things like this when you're young, improves your IQ as well. The better stimulated you are, especially while you're growing up. So, if I were to give an overall takeaway on this, parents tend to really overestimate how much they can shape the intelligence of their children in positive directions by buying them the right books or being more attentive and things like this. These differences tend to level out with age very quickly. You become more like your parents, intelligence-wise, the further from your childhood you get, the older you get. So a lot of the influences of parenting tend to level out over time. The main takeaway to get out of this in terms of helping your children versus not hindering them is just that it's very easy to damage a child's developmental processes and therefore impair their intelligence with abuse, malnutrition, lack of opportunity, but it is hard to improve above their genetic baseline just by giving them more things. As long as you get somebody to baseline, usually it's only people with superior or more fortuitous genetic endowments who are likely to be geniuses, things like this. So that brings us to the very end. I will see you all in the next online lecture, which will be on group dynamics. See you there.